For this video, I am going to discuss motion graphs, and we're mainly going to focus on position versus time graph. But first, let's try to understand how we read motion graphs. So there are three types of motion graphs. We have the position versus time graph, the velocity versus time graphs, and the acceleration versus time graphs. Now, before we learn to interpret specific types of motion graphs, we first have to know how to interpret the slope and area of a specific motion graph. So, whenever we have some quantity n is some quantity, graph against time, it shows the values of that quantity as time progresses. So, depending on the slope and area of the graph, you can get some interpretations. In particular, if we have this type of graph, what can you say? So, this is a line, which means it has a constant slope. And for this one, this is a constant positive slope because it is increasing. We have increasing trend, so it's positive, and the steepness doesn't change over time. So whenever you put a person here, or you put a person here, the elevation was changed, but the slope is still the same. The steepness is constant. What about if you have this one? We have this decreasing trend. So the slope is still constant. However, since this is decreasing, we can say that this is a negative slope. This is a negative slope. Constant slope, but a negative one. Then, how about if it's purely a horizontal line? What is it? Since we didn't observe a change with the value of n, or the quantity that we are interested in over time, then we can say that we have a zero slope. This is a constant value, which is zero, because there is no change with the value of n over time. Okay, so these are mainly the trends if we are talking about the linear graphs or linear trends. How about if it involves the ones with changing slope? So let's discuss that. If we have that one, so let me just delete this. If we have something like this, so this is n as a function of time. What can we say? If we're gonna compare a person here and a person here, we can say that the person on the right is on the flatter surface. So we can say that here the slope is decreasing. That's the trend. The slope is decreasing. What else? Aside from that, when you draw a tangent line to the curve, you can still see that it yields a positive slope. So while the slope is decreasing, it is also positive. So this is one. Slope is positive in decreasing because the steepness decreases over time. However, the slope is still positive. So you can imagine it to have a positive value, but the magnitude is decreasing. Next, what if you have something like this? What can we observe? If we can observe the position on the leftmost end and the rightmost end of this graph, we can say that the graph of the curve gets flatter and flatter as well. So with this, we can know that slope is also decreasing. Slope is decreasing. But what can we say about the sign of the slope? If we are going to draw a tangent line to that curve, what can we form? A line with a negative slope. So therefore, we can say that the slope is negative and decreasing. What are the other trends that we can see? So let's have another two. What if you have, how about it's not like this? What if you have something like this? Let's try to put it near approximate with the other one. How about if it's like this? We have this trend. What can we say? As time goes by, from left to right, if we're gonna put a person here that's like a side of a mountain, that's like on the side of a mountain, what can we say? It gets steeper and steeper. So what can we say about the slope? The slope is increasing. What about the sign of the slope? So if we are going to draw a tangent line to the curve to show that we have going back, what can we say about the slope of this? So the slope is again increasing because it gets steeper. You can imagine it to be a side of a mountain where a person climbs and climbs, just like the previous ones. As slope increases, sorry, as we go from left to right, the slope decreases because the side of the mountain gets steeper and steeper. And when you draw a tangent line hitting one of the points on that curve, this tangent line has a positive slope. So this is the case when slope is positive and increasing. Slope is positive and increasing. Okay, next. What about if we have this? If we have this trend this way, what can we see? So as we go from left to right, the slope gets bigger and bigger because if you compare a person here to there, the right side is much steeper. So we have an increasing slope. So the slope is increasing. But what can we say about the sign of the slope? So about the sign of the slope, if we are going to draw a tangent line to that curve at any point, so let's say we have drawn a line here. We just delete this. Let's say we have drawn a line here. What can we say? This line has a negative slope. So therefore, we can say that the slope is negative and decreasing or increasing rather. Okay, so these are the trends that we can see from the any graphs that we can see, not just motion graphs. But in particular, we want to apply this when reading a position versus time graph. Now, I just want to clarify that we have three types of motion graphs. We have the position versus time, velocity versus time, and acceleration versus time. But let's apply this in a position versus time graph. In a position versus time graph, the y-axis contains the position, the x-axis contains t. So we have here x versus t. X means horizontal position. So it could be y if we are talking about the vertical position. If we have something like this, what can we say? We first have to understand what the slope of a position versus time graph means. So suppose you have 2 points on the graph. So let's say you have this point and this point, and you want to get the slope of the line. So this is going to be T1, and this is going to be T2. On the other hand, this is going to be X1, and this is going to be X2. X1 and X2. So what can we do about this? So to find the slope, you're going to have to get the rise over run. So rise is X sub 2 minus X sub 1. Run is T sub 2 minus T sub 1. So the slope here is equal to the displacement, delta X, or the change in position, over the elapsed time. Now, are you familiar with this quantity? This is the velocity. This is the velocity. Therefore, the slope of a position versus time graph is the velocity. Let's put that here. The slope of a position versus time graph is the velocity. Okay. Now, let's try to interpret position versus time graphs depending on the trend. So let's delete this. Let's have this blue graph. A linear trend. So this is a linear graph. Let me just delete this. Okay. What about this? What can we say about the slope? Well, obviously, the slope here is positive and constant, just like what we had earlier. But then again, the slope of a position versus time graph is the velocity. So we can say here that velocity is positive and constant for this case. Velocity is positive and constant. What about if it's like this? So as you can see here, the slope is negative. The slope is negative, but since this is a line, a diagonal line, it is still a constant slope. It still has a constant slope. So we have here velocity is negative. Again, because velocity is the slope of this graph and constant. All right. Next, what about if it's like this? Just a horizontal line. No movement along the position. So here, we can say that we have a zero velocity. Why are we confident about that? Because you didn't move your position. The position was not displaced. So whenever you have a horizontal line, it has a zero slope. And since for the position versus time graph, the slope is velocity, you have a zero velocity. Next, you may also have this. Just like before. What can we say? As we go from left to right, the slope decreases. Look, from here to there, it gets flatter. If you're going to put a person here to a person here, it gets flatter. So the slope decreases. But what can we say about the sign? The sign of the slope is still positive because if you're going to draw a tangent line to this curve, you will yield a line or you will need to draw a line that has a positive slope. So for this case, we can say that velocity is positive velocity is positive and decreasing because the slope is decreasing. Next, if we have this one, here, what can we say about this compared to the other one? So compared to the other one, the slope of this graph increases. As you go from left to right, your slope increases, which means velocity is increasing. So velocity is increasing. But what can we say about the sign of the velocity? Drawing a tangent line there, the slope of this tangent line is positive. So we can say that velocity is positive and increasing. Next, what if we have these two cases for the cases where velocity is not constant. What about this? Let's try this. What can we say about the trend? So as we can see, as time passes by, the slope gets flatter and flatter. From left to right, it gets flatter. So we can say that velocity here is decreasing. Now, if you're going to draw a tangent line to the curve, you need to draw a line with a negative slope. So therefore, your velocity is negative and decreasing. Last, so we have these three. What else should we do? So for the last one, let's copy this. What about if it's something like this? Okay, so this is different from the ones above. What can we say about this graph? As you go from left to right, your slope increases. This side is much steeper. This side is much steeper. So with that, we can say that velocity is increasing. What about the sign of the velocity? Draw a tangent line here. You'll have a negative slope. The slope of this tangent line is negative. So we can say that velocity here is negative and increasing. So that would be for the position versus time graph. For our next video, we'll discuss velocity versus time.